So in this worksheet, we're going to be talking about the intersections of nonlinear systems in a little bit more complicated form than we looked at in the past. No, you were not. So, yeah, we didn't do part of those yet. Yeah. So, let's say that I had some equation that equaled, it doesn't really matter, 8. If I had 2x minus 4y, what type of graph is that? It's linear. We have an x to the first and a y to the first, so it's linear. What if I had something like x squared plus x minus 2y equals 4? That's quadratic. And really, the only exponents that matter are the largest exponents on each variable. So this is, it has a degree of 2. The exponent is a 2. And this has a degree of 1. So the y value is to the first power. The x value is squared. So this is a quadratic equation. It's going to be a parabola. And since it's the x that's squared, it's either a vertical parabola that opens up or down. If I were to switch it around and say 2x minus 4y squared equals 3, it's still a parabola, but now we've gone from vertical to horizontal. And it's either going to look like this or it's going to look like that. Okay, and for these, it doesn't matter if the x's are on one side or the y's are on the other. As long as you see y to the first, x squared, it's a parabola. If you see x to the first, y squared, it's still a parabola. We could also have like x squared plus 3x minus or plus y squared plus 2x equals 3. So in this case, we have an x squared and we have a y squared, and this is a little tricky. They're on the same side and they have the same sign. So this is actually a circle. If you have an x squared and a y squared, and they have the same sign on the same side of the equation, it's a circle. So if it was x squared equals negative y squared, it would still be a circle, because if I move this y squared to the other side, it would be negative. Does that make sense? Okay. If you have x squared minus y squared, or vice versa, equals anything, it's no longer a circle. It's kind of like an inverted circle. And it's called a hyperbola. It looks like this. Those are not parabolas. Parabolas are rounded and they get steeper and steeper and steeper, and eventually they're almost vertical. But hyperbolas don't do that. They have these slanted asymptotes, and each side of the hyperbola gets closer and closer to that asymptote. So they round out for a while, and eventually they just kind of go straight. They don't ever actually go straight, but they get so close to straight we can't tell the difference. And that's when your x squared and your y squared have different terms, or have different signs. Okay? Then there's one more. If we had like x squared and y squared, but the coefficients in front of them were different. So the x squared is getting multiplied by 4, and the y squared is getting multiplied by 5. And that's called an ellipse. It would look something like this. And an ellipse has two separate radii. It has a vertical radius, and it has a horizontal radius. And those radii are attached to these numbers here. So if it was 4x squared and 4y squared, it would actually be a circle, because the vertical radius and the horizontal radius have the same length. But if you change it so that the coefficients are not the same, then you end up with an ellipse. Now you don't need to know this for the worksheet we're working on today, but it is kind of nice to know if one equation is an ellipse and another equation is a circle, it's possible to have 4 intersections. or even if one of them was a parabola, you could still have 4 intersections. Okay? And we're going to study circles. I don't know that we get into ellipse, I don't remember. But hyperbolas have kind of died. We don't really deal with hyperbolas anymore. We used to. Okay, back to the worksheet. So on this first set, you don't need to solve them. All it's asking is, I have 2 equations, and just for fun, what kind of equation is the top one? It's a quadratic. Is it vertical or horizontal? It's a horizontal quadratic. What about the second one? It's also a horizontal quadratic. How many ways can 2 horizontal quadratics touch? 0 or everywhere or once or twice. So if I had one horizontal quadratic and then I had another, they could touch none, they could touch once, they could touch twice, or if they're exactly the same, they could touch everywhere. But these are obviously not the same. So how do I know if this point is a solution to the system? Plug it in. So let's say I plug it into the top and it says equals 0. What does that tell me? That tells me that point belongs to the first equation. Does that tell me it is an intersection? No. How do I find out if it's an intersection? Plug it into the bottom. So what if I plug it into the top and I get no? I don't need to do the next one. If you already know it doesn't work in one side, there's no point in plugging it in the other. Okay, so those problems are pretty simple. Let's do this one. So here, can you tell me what type of equation the top one is? An ellipse. It's an oval, right? Because they're both squared. We have an x squared and a y squared, and they have the same sign. And then one of the radius is bigger than the other. And actually, this radius is bigger, but you don't know why yet. It works backwards than you think. And then the bottom one is a line. So I'm going to use substitution to figure out where this line and this ellipse intersect. How many times can they intersect? Twice or once or never. So we're either going to get 0, 1, or 2 solutions. There's no way to get 3. So I'm going to put x equals negative 3y, and I'm going to plug that in here and in here. And again, there's not nearly enough room on this to solve it, so you're going to have to write this somewhere else. So 2 times negative 3y to the second plus 3y to the second plus 3 times negative 3y minus 12y minus 42 equals 0. Did you get that? Okay. So what is negative 3y times negative 3y? It's 9y squared, and what's 9y squared times 2? 18y squared plus 3y squared. This is going to give me negative 9y. Did I mess that up somehow? No. Okay. Negative 9y. Oh, I see. Now I combine like terms. 18 and 3 gives me 21y squared. Negative 9 and negative 12 gives me negative 21y minus 42 equals 0. The nice thing about this worksheet, all of the intersections occur at whole numbers. And because of that, all of the factors of these quadratics are going to be whole numbers, which means I can divide the 21. If you get to this step and the 21 does not divide out, you made a mistake. you will always be able to divide by this number. He's sleeping. You had 2 weeks to catch up on your sleep. Did you not do it? So I'm going to divide by 21. Y squared minus y minus 2 equals 0. Now what do I do? There are no like terms, and it's a quadratic, so I need to factor it. Are you guys to the point where you can factor without the box? So this is going to be y and y, and I want the factors of negative 2 that add to be 1, negative 1. Negative 2 and positive 1. What multiplies to be negative 2 and adds to be negative 1. So you really only have one choice here because 2 only has one set of factors, 1 and itself. So my roots are y equals 2 and y equals negative 1. So that's half my answer. Now I need to find the x values, and I have 3 choices. I can plug it in here, I could plug it in here, or I could plug it in there. And the equation you used for the substitution will always be the easiest one to plug it back into because it already says x equals. So if I put 2 in there, x would be, so x is negative 6, and that's one of the intersections. If I put negative 1 in there, I would get 3, so x equals 3. And that's how those problems work. Okay. Now let's look at the last 4 because they're a little bit different. So if you look at number 11, should I use substitution or elimination? Could I even do substitution? If we look at the bottom, is there any way to solve for x or for y? You could, but it would be really, really hard because we have a y quadratic and we have an x quadratic, and the only way, well, there are a couple ways to figure out what x equals in a quadratic. One is to factor, but factoring is not going to work because that would end up with 2 different x values. So factoring's out. The other way is to use the quadratic formula. So you would need to use the quadratic formula for y, but there are going to be x's inside the quadratic formula, so it would be like negative, it would be negative 20 plus or minus the square root of something with a bunch of x's inside. It's a mess. So we don't do that. So the bottom has no way to solve for x or for y that's easy. What about the top? Could I solve for x or for y? I could solve for y. Do I want to? No, you'd subtract the 5x over, you'd subtract the 20x over, you'd add the 7, and then divide them all by 9. And then you'd have to plug in that nasty quadratic with fractions in it, and it just doesn't work. But it turns out in this case, we can actually use elimination. What can we eliminate? Well, if I only eliminate the 5x squared, is that going to be enough? In order for elimination to work, either all of the x's have to go, or all of the y's have to go. Is there any way to eliminate the y's? I could times the bottom by 9, and then the 9y on top would cancel out the 9y on bottom, but I still have a y squared term, and elimination didn't actually happen. But I can eliminate the x's because I have a 5x squared on top and bottom, and a 20x on top and on bottom. So this doesn't happen very often, but when it does, it makes your life a lot easier. So what do I need to do in order for these to eliminate? times the top or the bottom by negative 1. So that turns into negative, 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 positive. So those cancel. Those cancel. What am I left with? (10y squared) minus 9y. Oh, wait. Negative 9y minus y. So this one and this one would give me minus 10y. And this one would give me minus 60 equals 0. Does it appear as though I've done it correctly? How come? I can divide by 10. So that's a really good sign on this worksheet. So divide by 10, y squared minus y minus 6 equals 0. So I've simplified it down to a quadratic. Let's factor it. Are there factors of negative 6 that add to be negative 1? So 3, y minus 3, and y plus 2. Okay. So my roots are y equals 3 and y equals negative 2. How many solutions does this have? We don't really know yet. What type of equations am I looking at? Well, the bottom one, it's not a circle because those are different. So it's an ellipse. It's an ellipse and a parabola, and it's a vertical parabola. So we have some kind of ellipse and a parabola. So it could hit 4 times or 3 or 2 or 1 or none. But it's at least 2. Okay. But notice, if it were to hit 4 times, there's a good chance that the y values are duplicated. Right? Let's say this was the graph. This could be 1, 2, and negative 1, 2. And 2, 4, and negative 2, 4. So we're going to take this and plug it back in, and there is a chance that this happens twice, depending on the equation. Which one would you stick it in? The top one. The bottom will still work. In fact, it'll give you the exact same equation. So I'm going to put negative 2 in here. And I get 5x squared plus 20x. 9 times negative 2 minus 7 it doesn't matter. So she asked, we changed all the signs. Well, it's still going to work. No matter if you change the equation, it will still work. I just preferred this equation because there are fewer negatives. So 5x squared plus 20x. 9 times negative 2 is negative 18. Minus 7 would be minus 25. So if you would have kept it, I would have had negative 5x squared minus 20x plus 25. But in order to factor, this needs to be positive. Okay, can I divide by 5? Yeah, so that's a good sign. So x squared plus 4x minus 5 equals 0. Let's try to factor it. Are there factors of 5 that add to be 4? Negative 5 to add to be 4. Negative 5 and positive 1. So x minus 5 plus 5 and x minus 1. So this is negative 5 and 1. So what's the intersection point? So yeah, both of these x's have that as a y value. Well, maybe not. This one might not have 2. Right? We know that this y value has 2, but we're not sure about this one yet. Because when I plugged that in, I got a quadratic that has two answers. If I would have plugged it back in and I only get one answer, it would only be one. But I plugged it in and I had a quadratic, so there are two answers. So -5, -2 is one of the answers, and 1, -2 is another answer. So there are at least three. Yeah, you can. It could look like this. Yeah. So let's plug in 3, and we'll see how many solutions there are. So I'm going to put 3 in here. 5x squared plus 20x. 9 times 3 is 27, and 27 minus 7 is 20. Can I divide by 5? Wait a minute. Something doesn't look right. Oh, no. It'll work. It'll work. So divide by 5. So we try to factor it. X and x. Are there factors of 4 that add to be 4? 2 and 2. So how many roots are there in this case? There's only one root, and it's -2. It's -2 and -2. So when I pair this up with this, I get -2, 3. And if you wanted to, you could write -2, 3 again. But it's the same point, so this actually has 3 solutions. I wouldn't. It's not incorrect. Okay. So if you take a look at number 12, what do you need to do in order to eliminate? Change the signs on one of them, and the nice thing is, not only do the y's eliminate, but the x terms also eliminate. So that's actually a really easy problem. Okay, what can you eliminate here? The x's. If you times the top by -1, then the x's will eliminate, and you'll be left with a y, with a quadratic y. Okay? Over here, what would you eliminate? So if you times the top by -1, and then the y squareds and the y's will eliminate, and you're left with a quadratic in x's. Then you find those two answers for that quadratic and plug it back in. So this is a horizontal parabola. So it looks like this. And the bottom equation would be an ellipse. So there's a possibility for 4 solutions. You could have 4, or you could have 3, or you could have 2, or you could have 1, or you could have none. It just depends on what the quadratics are. Let's say I simplified this down, so I canceled the y's and I'm left with x squared plus x plus 12. How would I know if this has no solutions? What do we do with this to solve it? We try to factor it. If it doesn't factor, does that mean it has no answers? No, it means it has no friendly answers. So you could graph this, and if that misses the x-axis, if this quadratic has no solutions, then this system has no solutions. But that's not going to happen. Okay? You will always get to a factorable quadratic. There are no solution problems in this. Okay? All right, get to work. Good luck.